Hello everyone, and welcome back to the Trending Tech Show. I'm your host, Alex, and today we're digging deep into one of the most fascinating and rapidly evolving areas of AI, Retrieval-Augmented Generation architectures in large language models, commonly known as RAG in LLMs. To help us break down this complex but crucial topic, I'm joined by Adam, an AI solutions architect and machine learning specialist. Adam, thanks for coming on the show.
Thanks so much, Alex. I'm really excited to be here and share what makes RAG such a pivotal technology in the AI landscape. It's an area full of innovation and real-world impact, so I can't wait to explore it together.
Fantastic. Let's set the stage for our listeners. In simple terms, what exactly is Retrieval-Augmented Generation, and why has it become such a hot topic in large language models?
Great place to start. Retrieval-Augmented Generation, RAG, is a method that supercharges large language models by allowing them to tap into external databases or knowledge bases in real time. Traditional LLMs, like GPT or Llama, rely heavily on the data they were trained on, which can quickly become outdated and may not cover very domain-specific or private knowledge. RAG changes that by letting these models search and pull in relevant, up-to-date information when needed, rather than relying solely on their frozen training data. So, when you ask a question, the model not only draws on what it knows, but also retrieves supporting context or facts from an attached database or document set before generating its answer.
That's a clear explanation. Could you give us a real-world analogy to help paint the picture even more?
Absolutely. Imagine you have a really smart assistant who's read every book up to 2023, but you need the absolute latest info or something from your private documents. With RAG, it's as if your assistant can also Google things for you or search your company's document library in real time before answering, making sure the information is both current and tailored to your needs.
That makes sense. It's like bridging the gap between memorization and live research. Can you break down how a typical RAG system actually works under the hood?
At its core, a RAG system has two main parts, the retriever and the generator. The retriever's job is to search an external data source, maybe a set of company documents, a vector database, or an online source, and pull out material that's relevant to your query. For example, if a medical chatbot is asked about a new drug, the retriever will look up recent medical journals or databases. The generation part then takes that retrieved information and weaves it into a well-formed answer using the LLM's language capabilities. So, the flow is, user asks a question, retriever finds supporting docs or passages, and the LLM generates a response using both its own training and this fresh context.
Sounds like there's a lot happening in the background. You mentioned vector databases and embeddings. Can you explain what those are in layman's terms and why they matter in this context?
Definitely. Let's break it down. When we talk about embeddings, we're referring to how computers convert words, sentences, or even whole documents into a kind of mathematical fingerprint. A long list of numbers that capture the meaning and nuance of the text in a way that's easy for machines to search and compare. A vector database stores these fingerprints, making it lightning fast to find passages that are semantically similar to a query. In RAG, when someone asks a question, the retriever generates that fingerprint for the query and quickly searches the vector database for the closest matches. It's way more sophisticated than the old keyword search you might know from web search.
So it's like finding similar puzzle pieces based on shape rather than just the color. Instead of hunting for just the same words, it's finding what really fits conceptually.
Exactly. That's a perfect analogy. This semantic search means RAG systems can actually understand the intent behind your queries, not just match keywords. That's crucial when you want accurate and relevant information, especially in nuanced or specialized domains.
Let's talk tools and tech. What are some of the main frameworks and platforms powering RAG systems today?
The system has grown fast. Some of the most popular frameworks are LangChain, LlamaIndex, and Haystack. These essentially provide ready-made modules that let developers combine retrieval and generation components efficiently. For handling embeddings, vector databases like Pinecone, Chroma, Milvus, and FAS are widely used. They're built for fast similarity searches across huge amounts of data. There are also up-and-coming tools like DiFi and Letta that try to make building RAG applications even easier by offering clean interfaces and back-end infrastructure out of the box.
Interesting. So if a developer wants to add live document search to a chatbot, these frameworks can help them do it without building everything from scratch.
Exactly. It's all about modularity and efficiency now. These frameworks abstract away a lot of the heavy lifting, so instead of spending weeks on low-level code, teams can focus on their unique use case, like integrating with internal knowledge bases or ensuring sensitive data is protected.
Speaking of protection, data security and privacy must be big concerns, especially when RAG deals with potentially sensitive info. How do experts address these risks?
Security is front and center when you're retrieving and using real-world data. Best practices start with strong access controls, making sure only authorized users and systems can see or modify sensitive information. Encryption is used for data both at rest, in databases, and in transit while it moves through the system. Some sectors, like healthcare or automotive, also require local deployment, meaning RAG runs inside a company's own secure environment, never leaking sensitive material to the cloud. On top of that, tools like NEMO guardrails or internal guardrail systems check every response for compliance or redaction needs, ensuring that nothing sensitive slips through by accident.
That's reassuring, especially for industries like healthcare or finance. Now, Adam, you mentioned chunking and re-ranking earlier. Could you unpack what those are?
When feeding large documents to a retriever, it's essential to break them into manageable chunks or sections. This segmentation, sometimes by sentence, paragraph, or logical boundaries, lets the retriever target only the most relevant part of a document, making retrieval both faster and more accurate. Re-ranking is the next step. After the retriever fetches a set of candidates, a re-ranker, usually another model, assesses their relevance to the original query so that only the best, most context-appropriate pieces are passed on to the generator. This layered approach helps reduce noise and focus on facts that really matter.
It almost sounds like we're building a super-powered research assistant, one that reads everything, finds the most relevant details, and only bothers us with the best bits. Can you share some standout examples of where RAG is making a tangible impact today?
In the legal sector, Thomson Reuters uses advanced RAG in its Westlaw Edge platform, giving lawyers real-time access to the latest statutes and case law. In healthcare, companies like Pfizer use RAG to synthesize the most current medical studies for drug discovery and decision support, helping speed up new treatments. On the customer support side, DoorDash upgraded their help desk with a RAG-enhanced chatbot, which retrieves answers from a knowledge base and ensures they're checked for accuracy and legal compliance before replying to users. GitHub Copilot applies RAG to fetch the most up-to-date code snippets, helping developers write better software faster.
Those examples really highlight how RAG is moving beyond theory to solve high-stakes, real-world problems. What about best practices for teams looking to implement a RAG system? What should they get right from the start?
The key is data quality and maintenance. Keeping your knowledge sources current and error-free is foundational. Use version control, rigorous validation before indexing, and diversify data sources to minimize gaps or biases. On the retrieval side, investing in distributed vector databases and GPU acceleration pays off with speed and scale. Fine-tuning retrievers and crafting targeted prompts for the LLM can dramatically boost answer quality. And don't forget ongoing monitoring. Track response latency and system metrics, and establish a feedback loop for user corrections or improvements. For deployment, managed LLM services can simplify scaling, but always plan for security, privacy, and ethical considerations.
I'm glad you mentioned ethics. As with any advanced AI, there's potential for bias or unintended consequences. How should organizations stay responsible while deploying RAG?
Responsible RAG means ensuring fairness and transparency at every stage. Use diverse, representative data sets and fairness-aware algorithms to minimize bias. Make the system's workings open. Communicate what knowledge sources are used, and be candid about any limitations. Conduct regular ethical and security audits, and be vigilant about redacting or anonymizing sensitive data before it enters your retrieval pipeline. Finally, prompt engineering and response filtering can help prevent harmful or misleading outputs.
Switching gears a bit, what are some of the latest trends or innovations you're seeing in the RAG space right now?
We're seeing big advances in multimodal RAG, systems that don't just use text, but can also retrieve and reason over images, audio, or video. For instance, a healthcare system might pull relevant X-ray images or medical diagrams alongside text data, offering richer answers to complex clinical questions. Collaborative RAG frameworks are also emerging, where different language models, small and large, work together to improve multi-step reasoning. On the technical front, Hybrid retrieval methods, combining keyword-based and semantic searches, are improving both recall and relevance, especially for complex or niche queries. And finally, more systems are incorporating real-time feedback loops, learning dynamically from user behavior to continuously refine their results.
That paints a picture of RAG systems getting ever more intelligent and adaptable. Are there any key challenges or limitations teams should watch out for as they push these boundaries?
Major challenges include computational costs. Running LLMs and high-performance retrieval engines isn't cheap. There's also the need for robust validation and monitoring, since retrieval pipelines can introduce subtle errors or sometimes pull in irrelevant content. Security and privacy get extra tricky as data sources become more diverse, and as RAG systems grow more complex, ensuring explainability and trustworthiness so that users and regulators know what's happening under the hood becomes even more important.
Let's wrap up with some quick-fire insights. If a company is considering RAG for their next AI solution, what are the first 3 steps you'd recommend?
First, clearly define your use case and curate high-quality, up-to-date knowledge sources. Second, choose the right tools. Modular frameworks like LangChain or LlamaIndex make experimentation easier and safer. Third, prioritize security and compliance from day one. Encrypt data, establish strong access controls, and regularly audit both content and model outputs.
Adam, this has been an absolute masterclass on RAG and its applications in LLMs. To recap for our listeners, RAG marries the language fluency of LLMs with real-time information retrieval, leading to smarter, more current, and more reliable AI systems. The technique is powering innovation in diverse fields, from healthcare and law to customer service and auto design. Implementation is more accessible than ever, thanks to powerful frameworks and best practice guidelines. But success depends on disciplined data management, robust security, and ethical deployment. Adam, thank you so much for joining us today and making the world of Retrieval-Augmented Generation both fascinating and accessible.
Thanks a lot, Alex. It was a pleasure sharing these insights. I hope this empowers more people to explore and responsibly build with RAG in their own projects.
And thanks to all of you for tuning in to the Trending Tech Show. Don't forget to subscribe and join us next time as we continue to explore the most exciting trends in technology and AI. Take care, everyone.